Hey everyone, meet Turtle, the newest all-in-one 3D scanner from 3DMakerPro. It's equipped with a 6.4-inch 2K AMOLED display. Let's power it up. The screen delivers crisp, high-contrast visual, and you can hook it up to your local Wi-Fi for file transfer and firmware updates. It's got 256GB of internal storage and 16GB of RAM. The fan runs continuously with both the air inlet and outlet position at the bottom. On the right side, you find USB-C port for charging and transferring files, along with the power button. And yes, it's fully compatible with NVMe drive. Once the drive is detected, a USB icon pops up and you can also transfer files to the PC app over Wi-Fi. What makes Turtle truly special is that it's the only 3D scanner on the market right now that lets you swap the sensor size depending on the object you are scanning. I'm holding the medium-sized module. It has 10 contact pins and snaps magnetically onto the base unit. Removing it is just as simple. Place the side tab and pull it out. Now let's check out the S module designed for scanning smaller objects. Here we have a depth camera, the projector, and RGB camera, and this is LED fill light. It's noticeably brighter compared to the earlier models Moose and Seal. And here's Moose, the model I reviewed last year. It only has 4 small fill lights compared to the larger ones on the Turtle. They upgraded the system so it performs better when scanning objects with high contrast color. And here is the Seal. Moose, Seal, and Turtle all rely on the same scanning technology, a blue structure light. The system is built around the structure light projector, a single depth camera, and an RGB camera. The depth and RGB cameras are actually the same unit, differentiated only by their filter. And here is the projector lens. This is the structure light projector element. It emits narrow blue lines that are clearly visible to the eyes. Each scanning module comes with 2 camera sensors, one dedicated to the depth and the other to RGB. Now let's look at the M module. Unlike the S, the depth and RGB camera have swapped positions, moving the depth camera further away from the projector. This design gives the M module a wider scanning range, though at the cost of lower resolution. And here's the L module. The projector and depth camera are spaced much further apart. Its focus distance is nearly a meter, and both the projector and field lights operate at higher intensity. Turtle also offers the option to connect directly to a PC without needing the base unit. It connects to the PC via a USB-C cable. Since there is no physical button, you will need to start the scan using the spacebar on your keyboard. If mobility isn't priority, you can opt to buy just the sensor module. It's priced at only $454 per unit. Or if mobility is essential, you can pair the control pad with the sensor module, priced from $1,359 for a single sensor up to $2,079 for 3. These are early bird price. The MSRP will be higher. So when it's not connected to the control pad, it operates like the Moose but with its own battery, meaning no AC adapter is required. The weight with the control pad is 760 grams, not the lightest, but certainly not the heaviest either. Let's kick things off with a resolution test to see how well it captures fine detail. For this test, I'll be using the S module mounted on the battery pack. Press and hold this button for 2 seconds to power it on. Then plug it in using the included USB-C cable. This is the latest version of JM Studio. You will need it to operate with the PC, and I will include the download link in the description. Wait a few seconds and the connection status will appear here. Click here to enter the project. I'm using the easy scan mode. Now I'm adjusting the scanner to find the proper scanning range. I watch the preview screen and adjust until the maximum surface area is visible. But something is off. The range indicator on the left shows the scanner as too far away, which isn't correct. I place the spacebar on the keyboard to begin capturing. The preview screen highlights the surface in green, showing what's being recorded, but the range indicator on the left still incorrectly reports that the scanner is too far. I press the spacebar again to complete the scan. I have been waiting for over 2 minutes and the software is stuck in the rebuilding process. This issue didn't occur when I tested with mousse or seal, so I had to switch to a different scanning mode. Press and hold the button for 2 seconds to turn it off. Press down on one side of the latch, then pull the scanner out. Now I will place it onto the control pad. From this point forward, I'll be testing Turtle in standalone mode. Tap on the new scan and it takes you straight into scanning mode. When I adjust the scanning range, both the preview screen and the range indicator shows aligned data. I like what happens with the PC software. There is a brightness adjustment control located on the left side. Number 4 looks fine for this owl figure. Press the start button. One thing I noticed, it can capture the black turntable, which wasn't possible with mousse or seal. So it can capture both the bright color owl and the dark turntable at once, suggesting Turtle has improved dynamic range. The preview displays the result as a colorized point cloud, and you can zoom, pan, and orbit to inspect it. It prompts you to build the preview point cloud. Just tap confirm. And here is the preview point cloud. And next I make a second scan to align with the first one. Tap on scan and it will prompt you to save the data. The second scan completed smoothly without any issues. I tap on done and save the scan. You can place a single scan dataset into a project, just like putting files into a folder. Just create a new project and click Add to Project to export to the select project. In JM Studio, click on Import from Device and it will display your computer IP address. From the control pad, tap on Export. I choose to export only the raw data without the preview point cloud. Here, you need to manually enter the IP address from JM Studio. It will then compress the file and transfer it to JM Studio. Tap on Import and the scan data will open in edit mode. But something is off. The raw scan data isn't fully shown here. Only half of the owl figure is visible. I already reported this issue to 3DMakerPro during earlier testing, but it still occurs randomly. So instead, I will export using the NVMe drive, wait for the USB indicator to show up, then tap on Export. This time I will select USB drive, and the writing speed to the USB drive is very fast. Before removing the USB drive, press this icon to safely eject it. In JM Studio, click on Import and select the export file from the USB drive. I'm going to remove the preview point cloud. Unlike the Wi-Fi method, the raw scan data here looks complete. Hold the Ctrl key and left click to remove. I do the same for the second scan. Click on the alignment icon. Since this figure has strong features, I will use automatic alignment. With the 3DMakerPro scanner, alignment must be done before point cloud fusion. Tap on Process and I will select the high setting for the best result. You can also set the resolution manually in the Advanced tab, but I have found the high setting gives a good balance between resolution and noise. And here is the result from the high setting. And on the left you can see the result from the manual resolution setting at 0.15mm. The manual setting produces poorer results in terms of noise. I will export the model in OBJ format for comparison. Before moving on, let me demonstrate how to align the scan data using the control pad. Click on this arrow. There is an alignment button in the lower right corner of the screen. First, use the Russell tool to remove the turntable. Do the same on the second scan. Then tap on Alignment button, select the two scans, and it will bring you into this page. Click on Aligned. With the control pad, only automatic alignment is available. There is no option for manual alignment. And here's the alignment result. You can also fuse the point cloud from within the control pad and create a mesh. These are my out collections, serving as reference for resolution comparisons. I've been collecting this data for over 2 years. Let's compare the Turtle S with the M module. The M module delivers much lower resolution, but its wider capture range improves tracking. That's why it's not suitable for smaller objects like this owl figure. Next, let's compare Moose and Seal. Moose delivers better scan quality with lower noise and slightly higher resolution. Moose is shown on the left and its resolution is noticeably better than the Turtle S. Moving on to Seal on the right, its resolution is higher but the noise level is also greater. Seal is shown on the left and its resolution is clearly higher than the Turtle S. Moving to the Vega. The Vega on the left shows higher resolution than the Turtle S. The MAV 3 also produces significantly higher resolution. Both MAV 3 and Turtle are the same type of structured light scanner. I rarely say this, but Metro X produces better results than Turtle S with noticeably higher resolution. Insta2 is a laser scanner and it produces better results than the Turtle S. And here's the picture in laser mode. The difference is also significant. The difference becomes even wider with the P1, the X1, the S1, and the Raptor. Otter's infrared mode also produces better results. And the same goes for the Otter Light. Looking from behind, Otter Light delivers noticeably better resolution. Next, we move on to the precision test using the eggshell. Since an eggshell isn't perfectly round, it naturally has about 50 micron out of roundness. I make 3 scans in different orientation to see if the Turtle S can align the data seamlessly. Turtle relies on geometric tracking. For low feature object like this, I need to add extra features so it can track efficiently. Since the object has a brighter color, I will lower down exposure. Something is off again, and this time when I plug in the USB drive, the icon doesn't appear. It's not detecting the same drive it recognized just 10 minutes ago. So I'm switching back to the Wi-Fi method. And surprisingly, the Wi-Fi method that failed just 10 minutes ago is working again. This time all low scan data has been fully imported into Jam Studio. I'll clean up all the turntable, click on Align tab. I'll try the automatic alignment. And the software failed to align the eggshell scan data. Let me try again with just one pair of scan data. and it also failed to align. The discrepancy between overlapping surfaces in each scan dataset is too high, and the software can't match the curves because turtle precision is too low. I ran the same test with the seal, and it was able to align the eggshell automatically, just like the moose I tested last year. Next, I run an accuracy test using a class 1 100mm gauge block. This block has an error margin of only 0.3 micron. The tip of the gauge block has a mirror finish, so I need to apply a thin layer of spray. When precision is low, achieving good accuracy becomes difficult. Turtle also lacks a calibration board, so it can't be adjusted to real-world dimensions. I imported the point cloud into BricsCAD, and here's what I found. The wall of the gauge block aren't at 90 degrees on either side. When scanning at 45-degree angle, the depth detection precision is quite low for the turtle. Let's check the dimension. I'll trace the wall lines on the left side. I will offset it by 100mm plus 8 micron for thermal expansion, since my loom is 7 degrees above 20. The dimensional accuracy isn't looking good. It's about 1mm too long. That's 1000 micron accuracy error. By comparison, the much cheaper Pika consistently stays under 50 microns. Next, I'll test for angular error. This is also a class 1 angle gauge. Next, I'll trace the lines along both sides of the angle and take the measurements. It reads 89.707, which means an angular error of 0.3 degree. And next, I run a color scanning test with the fairy. I'm still using the S module here to achieve the best resolution. The tracking performance is excellent, no need to add extra features to the turntable. Here's the color scan result from the Turtle S. I tried exporting it as an OBJ for a comparison, but the texture file doesn't map correctly in Substance stage, and it also fails to open properly in Blender. So I will have to compare it without the color texture. The turtle mesh looks comparable to the raptor in terms of resolution for this figure, but it produces noticeably higher noise. The Pika delivers a smoother surface with finer details. And when comparing with the MAV3, which is the same type of scanner, it produces a much finer mesh result. And here the MAV3 is shown on the left. Next, let's move on to thin shell object scanning, the speaker trim. I have applied spray as well to keep exposure low and reduce noise. Because I'm using spray, I can keep the exposure level set to 5. Tracking performance is very good. I think it's better than the moose. Here's the back side. And this will be a separate scan. The tracking performance on the back side is also very good. I have only made 2 scans, so they need to be aligned manually. The software will prompt you to pick 3 pairs of points using a right click, and here is the alignment result. After fusion, I noticed missing scan data on both the front and back, even though spray was applied. Now let's compare it with the Pika, which I recently reviewed. The turtle produces a rougher surface and the edge line shows overlapping walls. Looking at the back side, the turtle shows much higher noise and missing spots even though spray was applied. In my opinion, the turtle isn't suitable for reverse engineering tasks, especially thin shell objects, which are widely used in automotive parts. Next, let's test the M module. It's the same bike helmet I used for geometry tracking tests. With its many features, the M module tracks efficiently. Let's compare the result with the Pika I recently tested. The turtle is on the left. In infrared mode, the pickup produces a smoother surface with edge sharpness and resolution that remains comparable. On the black form, the turtle scan appears noticeably rougher. I use the M module to scan this scooter fairing. The tracking performance is very solid, but once tracking is lost, it retracts almost instantly. In this test, the M module produces no noise and the surface smoothness is on par with Clarity's infrared mode. This may be because the object contains no black surfaces. I use the M module to scan this scooter seat. The tracking performance is good. Here I notice the start and end point don't align. The drifting error has occurred. On the preview screen, the drifting is quite large. When I tap the process data, the software corrects the error and seamlessly realigns the start and end points. Let's compare with the picker in NIR mode. The Turtle M is shown on the left. This time the Turtle M produces higher resolution than the picker in NIR mode, as seen in the stitching seam line. Next, I'm going to use the M module to scan the car console and evaluate its tracking. And it seems to track very well. Let's compare the results. Turtle M is on the left while S1 in NIR mode is on the right. The Turtle M appears to capture sharper details, though with slightly more noise, while Clarity's NIR on the S1 managed to pick up more of the black knobs. Next, I compare with the S1 in laser markerless mode on the right. The laser scan still produces sharper results with less noise. And finally, let's compare with the laser marker scanning. The difference is very substantial. Okay, next I'm going to test the L module. Let's try something that is notoriously hard to track, this flat door panel. One thing I noticed about the L module is that when it loses tracking, it's difficult to recover, unlike the M and S modules. So I scan continuously to avoid losing tracking. And I think the tracking performance is very close to the Autolight in large mode. And here's the result of the door panel scan capture without any markers, but as I mentioned, the accuracy of geometry-based tracking remains questionable. Next, let's see if the L module can scan the entire scooter body. The capture range is smaller than that of the Autolight and the Auto in large mode. And once it loses tracking, it won't recover. No matter what I do, the L module won't retrack. Here's my collection of scooter scans. On the left is the Turtle L, while the other Autolight and Vega can capture the entire scooter. The Turtle L fails to recover once tracking is lost and cannot complete a full body scan. The surface appears rougher compared to the Autolight and Otter, but it still produces better results than the Vega in large mode. Here's a final test, the backside of the car panel. I'll scan continuously, ensuring proper overlap areas for stable tracking. Because I know that once tracking is lost, recovery is extremely difficult. I ended the scan at this corner because the L module refused to retrack. When the panel is white, the noise level is lower, and from a distance it looks comparable to the Raptor. But when you look closer, you will notice the projector stripes. Even after lowering the exposure to match the color, they remain visible. And you might wonder what happens if you swap sensors mid-scan. For example, starting with the S module for fine detail, then switching to the M module for better tracking. The answer is it's not possible with the Turtle. It will throw a warning message since each module uses different calibration data. They cannot be combined in a single scan session. Alright, we have reached the final part of this review, the conclusion. One thing to note, this is not a paid review. I have never received sponsorship or commission from any of the product I test. Starting with the price, the Turtle full set with all three sensors costs $2,079. By comparison, the other light and picker are around $600, but they don't function as standalone scanners unless paired with a fast phone. To make the comparison fair, I have added the cost of a new gaming phone, about $735 into the setup. Even then, the other light and picker still come in at much lower overall price. Moving on to precision, the Turtle failed the eggshell test while both the Moose and Seal passed. When precision is low, aligning multiple scans becomes problematic. And when precision is low, accuracy suffers as well. On a 100mm gauge block, it produced over 1mm of error, far too high for reverse engineering or 3D printing. Autolight maintains about 0.15mm error, which is still excessive. Pika's laser mode achieves under 50 micron, making it far more precise. On resolution, the Turtle underperforms the Autolight in every mode. It can capture more detail in medium mode, but at the cost of increased noise. The Turtle doesn't support markers, so it relies entirely on geometry. In contrast, both the Otter and Pika still offer marker-based tracking options. The S and M modules deliver solid tracking, and recovery is quick when tracking is lost. The L module, however, struggles with retracking. For reverse engineering, the Turtle's performance is poor. Small clips and edges appear blurred, noise levels are high, gaps and crevices are inaccessible, and thin shell objects pose a major challenge. In practice, it won't work for most automotive parts. When scanning sculptures, whether small or large, blue structural light still underperforms compared to NIR, even though 3DMakerPro has try to improve dynamic range with stronger field lighting. It also introduces more noise. The strong field light makes the Turtle unsuitable for human scanning even with eye closed. In standalone mode, the field light cannot be disabled. I received the Turtle review sample 3 weeks before making this video. During testing, I found the control pad software had random issues with file transfers, and the PC software couldn't be used for scanning at all. Overall, the software feels years behind Clarity's mobile app. This video is quite long, but 3D scanners are expensive investments. I wanted to show you the device from every angle so you have enough information to decide whether it fits your budget and workflow. Thanks to 3DMakerPro for providing the review sample. They have been transparent throughout and never interfere with the content of this video. I have done my best to highlight the device performance honestly. Thanks you guys for watching. I'll see you in the next video.